Okay, let's look at the min-max problem for this exam. And here we go. They give us a graph here. They give us a graph, and there's a sketch of the equation y equals f of x equals, the equation is f of x equals 3x squared, y equals 3x squared. And there's a point, 5 and 0, right down here, it's D. And A is the point A and 0. And B and E are points on the function. B right here, E up here. DCE is parallel to this axis right here. It's parallel. Okay, to the y-axis. And BC is parallel to the x-axis, which means it'll make this, these lines here, these 4 lines here, this thing right here is a rectangle. A, B, C, D is a rectangle, they tell you that. Okay, let's try the first question. It says, write down the coordinates of B in terms of A. Well, all you have to do, you've got the A coordinate of B because it's parallel, because it's got the A coordinate up here. It has to go straight up. This is straight above it, parallel to the y-axis, so it's got to have the same x values. So the x coordinate is A. But the y coordinate, if we've got an x coordinate, how do we find a y coordinate? We just take A and put it into function. So instead of 3x squared, it's 3a squared. But that's pretty important because you should look at your picture there and put A 3a squared. Because the next question here is determine the maximum area of the rectangle. So it's a calculus question. We're looking for a maximum. And they're asking for the maximum area of this. Well, the first question's pretty easy. The first part of the rectangle is pretty easy. How tall is this rectangle here? What's this dimension right here? The y coordinate, 3a squared. Well, that's one side. This other side's a little bit trickier because you go, D is 5, and A is right here, A and 0. How would we figure out this length here? Well, we take 5 and we take away A, and that gives us this other side to the rectangle. This side must be 5 minus A. So now it's pretty easy to see what's the area of this rectangle here. It's 3a squared times 5 minus A. And there it is. There's your first step. Then you go 5 times 3 is 15a squared. 3a squared times A and negative is negative 3a cubed. Now we have an equation for the area of that rectangle. But how do you do min-max? Well, you take the derivative and you make it equal 0. So you take the derivative, 2 times 15, 3 times 3 is 9. There's the derivative. We make it equal 0. We'd I'd divide by 3 here, but they just factored out 3a, which is fine. The two answers are a equals 0, but that's kind of meaningless. So the answer that makes sense, we factor out 3. 3 times 10 is 30. 3 times 3 is 9. This is the one we're going to get the answer from. It's 3 over, this is a little bit backwards. It has to be 10 over 3. It's 10 over 3. Make 10 minus 3a equals 0 and solve. Add 3a, add 3a, and then divide by 3, the number in front of a. You get a is 10 over 3. But they ask for the volume of the rectangle in units. So we have to go back to our area volume and replace a with 10 over 3 and put it in our calculator. We get 500 over 9, which is 55,56 square units. Or I would write units with a little square on top there, but that's the answer. And there you go.